The next topic is context switching. Allow me to explain what context switching is. A context switching is a process that involves switching of the CPU from one process or task to another. In this phenomena, the execution of the process that is present in the running state is suspended by the kernel, and another process that is present in the ready state is executed by the CPU. It is one of the essential features of the multitasking operating system. The processes are switched so fastly that it gives an illusion to the user that all the processes are being executed at the same time. Now, after knowing this, let us know about the steps involved in context switching. The steps involved in context switching are: save the context of the process that is currently running on the CPU, update the process control block and other important fields, move the process control block of the above process into the relevant queue such as the ready queue, input output queue, etc. Select a new process for execution. Update the process control block of the selected process. This includes updating the process state to running. Update the memory management data structures as required. Restore the context of the process that was previously running when it is loaded again on the processor. This is done by loading the previous values of the process control block and register. Let us move on to the next topic, which is scheduling criteria. CPU scheduling is a process of determining which process will own CPU for execution while another process is on hold. The main task of CPU scheduling is to make sure that whenever the CPU remains idle, the operating system at least select one of the processes available in the ready queue for execution. The selection process will be carried out by the CPU scheduler. It selects one of the processes in memory that are ready for execution. There are three types of process schedulers. Long-term or job scheduler. It brings the new process to the ready state. It controls degree of multi-programming, that is, number of processes present in ready state at any point of time. It is important that the long-term scheduler makes a careful selection of both input-output and CPU-bound processes. IO-bound tasks are which use much of their time in input and output operations, while CPU-bound processes are which spend their time on CPU. The job scheduler increases efficiency by maintaining a balance between the two. Short-term or CPU scheduler. It is responsible for selecting one process from ready state for scheduling it on the running state. Note: short-term schedulers only select the processes to schedule. It doesn't load the process on running. The CPU scheduler is responsible for ensuring there is no starvation owing to the high burst time processes. Medium-term scheduler. It is responsible for suspending and resuming the process. It mainly does swapping, moving processes from main memory to disk and vice versa. Swapping may be necessary to improve the process mix or because a change in memory requirements has overcommitted available memory, requiring memory to be freed up. It is helpful in maintaining a perfect balance between the input-output bound and the CPU bound. It reduces the degree of multi-programming. Let us look at what scheduling algorithms are. A process scheduler schedules different processes to be assigned to the CPU based on particular scheduling algorithms. There are 6 popular process scheduling algorithms which are going to be discussed: first come, first serve scheduling, shortest job next scheduling, priority scheduling, shortest remaining time, round robin scheduling, and multiple level queues scheduling. Now let's move on to the next topic,